The hypothesis of dark matter has an elaborate history. In the appendices of the book, Baltimore lectures on molecular dynamics and the wave theory of light, where the main text was based on a series of lectures given in 1884. Lord Kelvin discussed the potential number of stars around the Sun from the observed velocity dispersion of the stars near the Sun, assuming that the Sun was 20 to 100 million years old. He posed what would happen if there were 1,000 million stars within 1 kiloparsec of the Sun, at which distance their parallax would be 1 milliarsec. Lord Kelvin concluded, many of our supposed 1,000 million stars, perhaps a great majority of them, may be dark bodies. In 1906, Henri Poincaré in The Milky Way and Theory of Gases used the French term matière obscure, dark matter. In discussing Kelvin's work, he found that the amount of dark matter would need to be less than that of visible matter. The second to suggest the existence of dark matter using stellar velocities was Dutch astronomer Jacobus Kapteyn in 1922. A publication from 1930 points to Swedish Knut Lundmark being the first to realize that the universe must contain much more mass than we can observe. Dutchman and radio astronomy pioneer Jan Oort also hypothesized the existence of dark matter in 1932. Oort was studying stellar motions in the local galactic neighborhood and found the mass in the galactic plane must be greater than what was observed. But this measurement was later determined to be erroneous. In 1933, Swiss astrophysicist Fritz Zwicky, who studied galaxy clusters while working at the California Institute of Technology, made a similar inference. Zwicky applied the virial theorem to the Coma cluster and obtained evidence of unseen mass he called dunkle materie, dark matter. Zwicky estimated its mass based on the motions of galaxies near its edge and compared that to an estimate based on its brightness and number of galaxies. He estimated the cluster had about 400 times more mass than was visually observable. The gravity effect of the visible galaxies was far too small for such fast orbits. Thus mass must be hidden from view. Based on these conclusions, Zwicky inferred some unseen matter provided the mass and associated gravitation attraction to hold the cluster together. Zwicky's estimates were off by more than an order of magnitude, mainly due to an obsolete value of the Hubble constant. The same calculation today shows a smaller fraction, using greater values for luminous mass. Nonetheless, Zwicky did correctly conclude from his calculation that the bulk of the matter was dark. Further indications of mass-to-light ratio anomalies came from measurements of galaxy rotation curves. In 1939, Horace W. Babcock reported the rotation curve for the Andromeda Nebula, known now as the Andromeda Galaxy, which suggested the mass-to-luminosity ratio increases radially. He attributed it to either light absorption within the galaxy or modified dynamics in the outer portions of the spiral and not to the missing matter he had uncovered. Following Babcock's 1939 report of unexpectedly rapid rotation in the outskirts of the Andromeda Galaxy and a mass-to-light ratio of 50, in 1940 Jan Oort discovered and wrote about the large non-visible halo of NGC 3115.